Alright, today we're discussing a turning point. At the 2025 shareholders meeting, Elon Musk highlighted the new capabilities of Optimus Gen 3. It's no longer just a concept, it's walking through Tesla offices, self-charging, and performing human tasks precisely. From folding clothes and handling kitchen utensils to collecting and sorting trash. It cleans surfaces, moves indoors wirelessly without an operator, and handles delicate objects like eggs or popcorn kernels. It's also demonstrated body control with martial arts movements, showing advanced balance, and was even seen dancing during the conference. This strategy builds on a fundamental idea: humanoids performing most physical work cheaply and continuously, causing the cost of goods and services to plummet. The approach discusses sustainable abundance with a potential tenfold increase in the global economy, making basic necessities more affordable and reducing poverty. Regarding capabilities, they emphasize that the robot learns through observation. Tesla's approach applies its autonomous driving neural network philosophy to the robot's body, enabling it to see, understand, and execute in one unified flow, trained with first and third person video and using simulation for rare or dangerous scenarios. This method has enabled rapid progress. The robot folds clothes skillfully, applies gentle force to avoid breaking eggs, and sufficient strength to handle heavy objects, all functioning in real-time automated operation. In hardware, they've stated the biggest challenge lies in the hand and forearm. It's described as the most difficult electromechanical component of the entire project. The goal of human-like dexterity requires pressure and touch sensors on each finger, real-time force control, and many degrees of freedom. The announced Gen 3 configuration features 22 degrees of freedom in the hand, 3 in the wrist and forearm, totaling 25 per hand, with fingers that can apply adaptive force to objects. Due to the manipulator's complexity, several revisions have been necessary. Overheating issues and extended cycles forced a redesign of the actuators, coinciding with the departure of the robotics lead who oversaw mechatronics. Tesla frames this as an engineering review phase, but markets interpreted it as a sign that mass production still needs further iteration. In the release schedule, the robot shown in 2025 was described as version 2.5, with plans for Gen 3 production in 2026, Optimus 4 in 2027, and Optimus 5 in 2028, featuring annual improvements in mechanics, materials, and AI software following smartphone-like production cycle. Additionally, integration with Neuralink is planned, as the company has already demonstrated brain-controlled cursor movement in humans and aims to bring this control interface to Optimus. The concept is that you won't need to control each joint or think, grab the cup, or store the box. Instead, the chip will read your intention, the AI system will generate the plan, and the robot will execute it while adjusting trajectory and force. They also mentioned the goal of bidirectional feedback, allowing users to enter the robot's body, see through its cameras, and feel pressure, temperature, or vibrations through the interface. The possibility of transferring aspects of consciousness to a robotic body in future decades has even emerged as long-term speculation. Meanwhile, the first practical approach is disability assistance through remote control and sensory feedback. The economic positioning is strengthened by the target cost of $24,000 per unit and a selling price between $20,000 and $30,000. Critics argue the real cost is much higher, potentially by orders of magnitude, which would significantly limit the market. The project responds that mass production and vertical integration should reduce costs over time, with goals to eventually lower prices to $10,000 per unit. The plan leverages factories ready for high volumes, integrating batteries, electronics, and proprietary computing, establish supply chains and expertise, reducing costs in sectors like electric vehicles. Regarding Optimus, the plan isn't just about manufacturing but integrating it into Tesla's ecosystem. In summary, we're presenting a robot that autonomously navigates Tesla facilities, learns through observation, handles both fragile and heavy objects on the same platform, and aims for production in the millions at an aggressive target cost. The goal is to accelerate towards sustainable abundance through automated physical labor by solving hand dexterity, advancing AI in unstructured environments, and scaling up production. Meanwhile, other players are raising the bar in natural movement, human interaction, and specialized applications. What will determine success is the ability to convert numerous actions into daily operations, maintain yearly iteration cycles, and meet the proposed cost and volume targets.